ว่า agoda เพิ่มความเร็วในการทำงานด้วย open stack ค่ะแล้วก็จะบรรยายโดย2ท่านนี้นะคะขอเรียนเชิญคุณมิสเตอร์มาร์คฮอลโลค่ะท่านคนนี้นะคะขอเสียงปรบมือต้อนรับด้วยค่ะคุณมาร์คฮอลโลเป็นผู้จัดการด้านโครงสร้างพื้นฐานของเซิร์ฟเวอร์ฝ่ายเทคโนโลยีสารสนเทศค่ะแล้วก็อีกหนึ่งท่านนะคะมิสเตอร์คริสซอฟลันค่ะค่ะท่านเป็น Senior System Engineer Web agoda.com วันนี้จะบรรยายในหัวข้อ agoda เพิ่มความเร็วในการทำงานด้วย open stack จะสนุกสนานขนาดไหนติดตามได้เลยค่ะ
Yes, thank you very much, everyone. So today I wanted to talk about how Agoda are using OpenStack. To begin with, I'll give just a summary of what we're doing and a summary of sort of where we came from, how we're using the technology, how it evolved, why OpenStack, and answer some of those questions. And then Chris will talk about some of the technical details, how we implemented it and how we're using it. So a little bit about myself first. I've been using Unix systems about 20 years, programming for 30 years. I'm self-taught as well. I have a degree in classical music, so all the IT stuff I learned just from reading. I've been working with various businesses over the last 20 odd years. Sun Microsystems being the biggest. I was with them for about 10 years in the UK and Singapore. I headed up their IT teams in Europe, Middle East and Africa as their technical lead. Now with Agoda, part of Priceline Group, been with them about 2.5 years now. So do we have any Agoda customers here? Does everyone know who we are? Does anyone not use Agoda? No. No one. Okay, very good. So I took this slide from the About Us page on our website. So you can see from here it's a fast website, it's easy to use, and it's using award-winning technologies. So what we're trying to do is bring together the best technologies we can find to support the use cases that we have. One of those technologies is OpenStack. This is what enables what we call velocity. I'll explain the concept behind velocity in a minute. But OpenStack, for what we're using it for, is a controller for compute resources, for networking, and for storage. It also does a lot of other things, which we're not currently using, but we may do in the future. So velocity, this isn't a product or anything, this is a concept. So it's measuring the rate of change. So how quickly we add new features into our applications, how frequently we can deploy into our data centers. With applications, it's fairly easy to use agile development. We can deploy every week, every couple of weeks, depends on how long the sprints are. But with infrastructure, normally you don't have agile infrastructure, but that's what we're aiming for. We want to be able to change quickly. Should point out that everything we do is A/B tested as well. So all of our applications, for example, when you search for a hotel, we've got multiple versions of that page running at the same time. We have small changes on them, and we test which one is most popular with our customers. Whichever version gets the most bookings wins, and that one stays on the website. The others are removed. And then we develop forward, we iterate, and bring out new features, A/B test them all the time. So with our infrastructure, we need to move with a sense of velocity as well. We need to be able to support what the development teams are doing. We need to be able to roll out changes very quickly. before we had OpenStack, I've put here a long, long time ago, but it was only a year ago, all of our servers were installed manually. They were administered manually. All of the applications installed, configured, administered, all manually. And with our scale, we're talking about thousands of servers, data centers on 3 continents. We can't do things manually anymore. It takes too long, it's not consistent, and we can't keep up with the pace of the application development. Also, a year back, we were mostly running on Windows. That's now changed, and we're also mostly on Linux. Our front-end systems, the agoda.com website, those are still Windows. Almost all the back-end technology is now on Linux. So as I said here, we need this to scale quickly. We need it to have high velocity, and the automation is essential for this. So to answer this challenge of how do we achieve velocity with infrastructure, we want to be able to install and configure all the servers automatically. A lot of our applications scale out horizontally very well, so we don't need large servers. We can use commodity hardware for this. We can add virtualization layers onto our servers, and then we can control that virtualization programmatically. We can write software to control our infrastructure. So this is what we have at the moment. We have what we call bare metal deployments, where we have the OS installed directly onto the hardware. There's some older deployments, 1 application per server. Most of what we do is commodity hardware. We're talking about 2 CPUs per server, 60-odd gig of RAM, a couple of 100 gig hard drive, 10 gig networking. It's all fairly standard. But we do have some larger databases. We have some large SQL Server systems where we've got 30 plus CPUs in the servers. We have some secure applications that we don't virtualize. We keep them in secure networks. These are applications that process customer data, such as credit card information. And then finally, the other bare metal systems are the hypervisors. This is what we virtualize on top of. These hypervisors are mostly OpenStack. We do have some Hyper-V. We have a little bit of VMware as well. 99% is OpenStack though. So I'm going to pass over to Chris. Having given you a bit of background on where the technology comes from, Chris can talk to you about some of the technical details and how it's implemented.
Hello. Okay. Thanks, Mark. Very nice. Yeah, I talk a little bit about the technique behind OpenStack, how we set it up. It's a complex product. You can set it up in many different ways. I set up a small agenda. So first I want to talk a little bit about me, then about Kickstart, how we do our deployments. Then I want to talk about what is OpenStack, what people expect about it, what is it not. A little bit insights about OpenStack, what are the components, how is it built. Then the Agoda insights, how we set it up, what is the scale, how we use it. And beside OpenStack, we use a lot of different open source technologies. And it's kind of a whole concept, and I want to talk about other infrastructure services, what we use with OpenStack, which are also open source. So about me, I wrote my bachelor's thesis about virtualization and SAN networks. So this was the first time I came in contact with virtualization and this cloud thing. Then my master thesis was especially about OpenStack. I set it up for a hosting company in Germany. Beside my studies, I worked all the time in the IT field as a system engineer, as a system administrator, like 5 years. I joined Agoda 2 years ago, and since then I'm working in the virtualization environment. I work also on mostly all the large-scale IT infrastructure projects, which is virtualization, monitoring, and log management. And besides this, I like traveling and I'm interested in esports. That's it. That's how we use automation in Agoda. It's our deployment process, a part of it. So it's kind of abstract. I don't want to go in the very deep detail. We use lights out management on the servers. On HP, it's called ILO. On IBM, it's called different. I don't know. We use Kickstart in combination with Cobbler as a web interface to install our bare metal machines. In Kickstart, you have profiles, so you can say when I want to install a server, this should be a Hadoop node, this should be a CentOS 6 or CentOS 7 minimal installation, or a compute node. Compute node is part of the OpenStack setup. When developers are asking for a server, we can kickstart it with Kickstart and Cobbler, and then sometimes they deploy their apps with Puppet on top of it. We also can put it in the Kickstart profile as an RPM or scripts for the application. And compute nodes, it's part of OpenStack, and this is what I want to talk about it. So what is OpenStack? OpenStack is infrastructure as a service. I like the term infrastructure by API more because in the end, OpenStack just provides you an API to get the stuff you want, and what you get is basically you can choose the data center. As Mark told already, we have data centers in 3 continents. So in our setup, you can choose in which continent you want to have your VM on. You can choose the networking. We have the basic firewall zones, front end, back end, what everybody knows. You can choose the compute resources. So let's say I want to have 2 CPUs, 2 gig of memory, and a disk size. Our virtualization layer is KVM. We mainly use KVM. We did some experiments with Hyper-V, but in the end we use KVM. And at the end of the stack of IaaS, you get your server. What is OpenStack? Of course, it's open source. That's why we are all here. I want to point out that it's also free. I don't like the fact that open source is just measured by I don't need to pay for it. It's a lot more. It's flexible, so it's not depending on a vendor. It's customizable, so when you want to have something implemented, go ahead, do it yourself, right? You can see the code, you can change the code. OpenStack has an active community. We use it quite a lot. We make mailing list posts. We did some bug reports. And this is important when you want to use OpenStack on a large scale. You need this support. OpenStack is also kind of an industry standard. It's covered by the OpenStack Foundation, which almost all the big vendors are participating, like HP, Intel, Cisco. At the moment, it's about 3,500 companies. I checked it yesterday. The development is driven by the users or by the vendors. So you don't have something like VMware, Hyper-V, where Microsoft or VMware dictates you how to use it. The development is driven by the people who actually use it. And it's proven. It's used in one of the largest clouds on this planet, like CERN in Switzerland, or eBay use it as well, for example. What is it not? OpenStack is not perfect. So when you want to set it up or you want to do your proof of concept, don't think it will be easy. There, on the basic components, it's like 500 configuration options. So you need to take a look at some of them. Some of them have dependencies, so you need to understand what they're actually doing. When you hear people talking about OpenStack, it's called a story. Story sounds like something long term, and it makes you busy. It's a story. It's not just setting it up and it works perfectly. So you need to spend some time with it. You will find bugs. So you will find things who not work as you want to work. Make a bug report. Let people fix it for you. It's not fully enterprise. So it's still at the beginning. I think it's 3 years old now since the first release. I'm not sure. It's still not there in the enterprise level. For example, at the moment we are working on the upgrade process. There is no tutorial, no step-by-step way to doing it. You need to figure out by yourself. Each cloud is different. The release cycle is 6 months, which is quite fast for an enterprise system. There are no long-term releases, so you need to catch up with the upgrades, which is not standardized, so it's quite a challenge. Here's some numbers. This is from the OpenStack survey. They do it twice a year, I think. They meet up, and then they ask people how they use OpenStack. It's quite interesting numbers. This is based on 1,200 companies who participate in this survey. I like it because it shows how OpenStack is used. Compute instances is the number of the percentage in this example of the servers where the VMs run on. You can see it mainly used in smaller scales. So small means under 1,000 cores. There are not a lot of people who are actually using it in large scale clouds, like 10,000 cores and up. So when you use it in a really, really large scale, you experience things what nobody experienced before. So it's kind of interesting. These are the basic OpenStack components. We have compute, Nova, which is the part where the VMs are running on. You have the Neutron part, which provides the network. You have a dashboard, Horizon. It gives you the basic functionality. It gives you all the things you need to start up. You have the image service Glance, which provides the basic images. At Agoda, we provide Windows 2012 R2. We provide CentOS 6, and we just about to provide CentOS 7 as well. There are a lot more components like Keystone, Silometer. With each release, there are more and more services you can use. Here's some facts about how we use it. Our first production instance was spawned almost nearly a year ago. It was a web server. It's still running fine. A year ago now. We started experimenting with the Havana release. Now we are on Icehouse, currently working on the upgrade to Juno. We mainly use our compute nodes with CentOS 6.5 and 6.6. As I said already, hypervisor is KVM. We have 4 separate clouds in 3 continents, so people who use our OpenStack setup can choose the continent. And we have 1 continuous integration cloud and 4 QA. So when QA want to test some new applications, they have their cloud and can spawn instances. We also do development against the OpenStack APIs. We use hooks for DNS entries. So when you spawn your VM, the DNS entry is automatically created. When you delete the VM, the DNS entry gets deleted. Basic stuff, but it's not included. Developers are using our API, and our team use it as well. We currently working at our own dashboard. So the Horizon dashboard provides you everything to start up, but when you want to use it in a larger scale and with some further improvements, you can write your own web interface. We are doing it right now. It's a super early version, but it's working so far. We set OpenStack up in a HA architecture. That's it. We use HA proxy with a VIP in an active passive setup. Everything communicates with this VIP. So all the compute nodes, we have two management nodes, the DB server and our image server. Our image server is a little bit special. The images are shared with a cluster setup. So when you upload the image to one of the servers, it will be automatically replicated and available on the other instance. So what are the next steps? So we have OpenStack in place. We have it high available. It's working. We're working on the upgrades. There are things you can do more. So at the moment, OpenStack sits on top of our data center, which means the firewall rules are still made in the switches, not controlled by OpenStack. You can extend the usage, so OpenStack can be your data center, right? OpenStack can control the switches. And at the moment, with OpenStack, you get your VM, right? There are some interesting developments going on with the Ironic project. So it would be nice to have the option to choose the option to spawn a VM or spawn a bare metal machine. And containers, it's also a big topic right now. Would be awesome to have the option to choose one of these trees. And at the moment, we don't use Cinder, which provides the storage. Could be interesting. It's a nice feature. And our compute nodes are using local storage. We thought about the proof of concept to use shared storage between the compute nodes. For network, we rely on the network team. So when we need a VLAN or a subnet, we need to request it. Would be nice to have it managed by OpenStack. It's possible. Also firewalls. It's set in the switches. OpenStack provides the ability to set host-based firewalls, which we don't use, but it's possible. And these are some of the infrastructure services we also use. We use Sensu for monitoring, or about to use it. We are in a proof of concept now. We use Graphite for monitoring or for stats. The funny guy on the right side, on the top, is Logstash. We use it for log management. On the left down, it's Elasticsearch. We use it in combination with Logstash. And Kibana for visualize the log. We have a lot more services. It will fill up a lot many slides. Agoda is changing, as Mark said already, from Windows to Linux, which comes with open source. So a lot of interesting stuff is going on at the moment, and it's a nice thing. Okay, that was my part. I will give it over to Mark.
Okay, thanks, Chris. So just a couple of slides to finish up. Looking over the last year, we've put OpenStack live. As Chris said, we have it in 3 continents, 4 data centers. We have thousands of VMs running in production. We also have development systems on there as well. Development and production systems run together at Agoda. So, you know, does this all scale? Does it work out? So with Kickstart, we can install racks of servers in just a couple of minutes. So, you know, if we have 40 servers per rack, a couple of racks, 80 servers, deploy them in just a few minutes. It actually takes longer for our servers to go through their BIOS checks than it takes to install the OS. Within the last year, Chris showed you some of the stats from the OpenStack survey about the size of some of the clusters, where the largest category was 10,000 CPU cores or above. Within 1 year, we're in that category. So we're one of the largest OpenStack users in the world. Some examples of how it's being used. We have Puppet for deploying our applications, and one of our developers was working on this and wanted to test how quickly he can deploy apps. So we just spun up 100 servers in a couple of minutes and let him test on it. We have other teams wanting 160 servers in 4 data centers. Again, it just takes a few minutes to deploy them. And then we had another business partner come in, and we needed to double the capacity for searching hotels. Again, no problem. We can do that. It just took us an afternoon to set up some more app servers. It's certainly not complete, the work that we're doing. As Chris mentioned, there's lots of other features in OpenStack that we could utilize later on. We need to do more for automation, and there's more technologies out there we need to test. Part of the role of our team is to test these new technologies and see what benefits they'll have to the business. So regarding that, we're hiring at the moment, if any of you are interested. So we're looking for a software engineer to join the team. We're working on, well, you've got the technologies listed there. We're a very international team. We've got Thai, English, German, Australian, French and Cambodian people in the team. I said come and have a chat with either of us. My email address is on the bottom there. So I look forward to hearing from all of you. Thank you very much, everyone. Any questions for either me or Chris? Okay, well, do come and catch up with us later on if you do want to ask anything, like what's the salary. We'll be around, so yeah, do come and chat with us, and thank you very much for your time.